In this tutorial, I'm going to show you how to do a simple one-way analysis of variance. We're going to first do it with just 2 levels of a single factor, and then we're going to do it with 3 levels or treatments of a single factor. So open up the Anova worksheet, and there's going to be 2 tabs. I probably have set it for accidentally to open up on the 3 groups tab. Make sure that you're in the 2 groups tab for this first part where it says do this first. All right. So here we have koala masses in urban and suburban territories, and we are hypothesizing that urban koalas are going to be larger than suburban koalas. So to do this, the first step is to calculate the urban mass average, then the suburban mass average, then the grand average. And we can do that over here. And you can use a pivot table if you would like, or you can just type in the averages. It's probably best to get in the habit of using a pivot table, so let's go ahead and do that. We're going to select all of that data and then go to Insert, Pivot Table. And let's insert it in this same worksheet here, so let's put it into worksheet right here and click OK. And then we have in our pivot table fields over here. Remember, if this is not available, make sure that you click on the pivot table analyze tab, and then you should be able to click on field list. That will toggle on and off that. Alright, so the pivot table is located right here, and we are going to place area into rows, and then we'll put koala mass into values. Now remember that Excel puts the default as sum. We want to change that to average, so go ahead and check average. And now we have our suburban and urban averages. Now, as a general rule of thumb, Excel will never give you the I'm going to paste this over here, give you the means in the order that you want and whatever. So we're going to type this in. Urban mass is 33.02, and let's type in suburban mass is 25.07, and then the grand total mass is right here, 29.05. Now, just as a reminder, you could calculate all of this stuff by hand if you just typed in average and then urban mass. You just select your urban data points, and you would get 33.0, and then you could do your suburban, and then your grand would be all of it. But I find the pivot table to be much, much more easy. All right, now once we have our averages, now it's time to calculate the variation around those averages. The first average that we're going to calculate, the first values that we're going to calculate is going to be our among group square differences. So between C and D, insert a column, and you're going to type in among differences. Now this is the among group differences. Now because we have 2 curves here, and those curves, by definition, the average between those 2 curves is going to fall directly in between those 2 curves. And you're going to have an equal amount of variation on both sides. That's the definition of a normal curve. We are actually going to get the same among square differences for all of the data points. This isn't going to be the case for our 3 groups practice, but it will be for the case for the 2 groups. So let's try this. The among group difference is equal to the urban mass minus the grand mass squared. Don't ever forget to square it. If you ever get zeros or negative, if you get a negative number, you know that you did not square it. Okay. Now we want to do this for all of the urban data points, and so we're going to lock G4, and we're also going to lock G6. And remember, you can use the shortcut key F4, function key F4. And then we'll go ahead and drag this down. Now we can drag this down all the way to the end of urban. I actually recommend dragging it down one more to suburban, and the reason is because you can now click on that, double click on that, and we can change the urban mass to the suburban mass simply by clicking and dragging the outline of that cell. Done. Now you notice, as I said before, there's exactly the same, because when you have 2 curves, all right, when you have 2 normal distributions, then the mean of those normal distributions is going to be right in between. And so by definition, the difference from the urban mass mean to the grand average and the suburban mass mean to the grand average is going to be the same by definition, because we only have 2 groups. So you have this, and it's going to be 15.8 all the way down. So we can click and drag that down. And now we have our among differences, our sum of those squared differences. And if you want to help yourself out, you can say among squared differences. The sum of those among squared differences is equal to the sum of all of those values. You could also just say 15.8 times 100. That would work too. There is our sum of squared among differences. Our degrees of freedom for among is equal to the number of groups minus 1. So it's equal to the number of groups, which in this case there's 2 groups, so 2 minus 1, or 1. Then our mean sum of squares, or average sum of squares, however you choose to say it, is equal to 1580.1 divided by our degrees of freedom, or 1. It's just 1580.1. Now let's not worry about the f value and the p value just yet because we can't calculate them. Double click on this little line right there to expand the cell D so that you have the entire among square differences text in there. Let's go ahead and insert another column between E and D, and we'll say within squared differences. And for this one, what we are going to do is calculate the within group differences between the individual data points and the group mean. For the first data point, the individual data point is 34.5 for urban. So we're going to say urban data point, 34.5, minus the urban mass group mean, the urban group mass mean, or whatever you like to say it, 33, and don't forget to square it. Now, we want to drag this down. We want this value to move down, but we don't want to change the urban mass. And so we're just going to lock H4. And let's drag this down for all of the urban data points. Now, we can actually drag this down one more to the suburban data point, to the first suburban data point. Double click on that, and just as we did before, what you're going to do is you're going to move that down by clicking and dragging to the suburban mass, and just press enter. And now go ahead and click and drag that down, and there is all of your within group square differences. All right, let's add up all of those, the sum of all of those. And we should get 384.1. Don't worry if it's left aligned versus right aligned. Our degrees of freedom for this is equal to the number of groups, which is 2 groups, times the number of replicates within each group, which is in this case 50, minus 1. And you should get 98. The mean or average sum of squares is once again is equal to 384.1 divided by the degrees of freedom. Now for our total, and this isn't really absolutely necessary for you to calculate, but I will ask you just to calculate it. This is our total, or our let's say our total square differences. For this one, this is every single box is equal to the data point, the difference between the data point and the grand mean squared. So is equal to the koala mass for that data point, for that row, minus the grand mass, which is always going to be 29.1 in this case. And don't forget to square it. Now we want to lock that grand mass. We want this to move, but we want to lock that grand mass. So use the F4. Right? So we've locked I6. And just carry this all the way down because it's always going to be the same subtraction. All right? And then add that up. And you should get 1,965.8. The degrees of freedom for this is the total number of replicates times the number of groups. So there's 2 groups times the number of replicates within each group, which is 50, and then minus 1, and you should get 99. The mean sum of squares, or the average sum of squares, is equal to the sum of squares divided by the degrees of freedom. You should get 19.9. And now we can go ahead and calculate the f value. The f value is the ratio of the among to the within mean sum of squares. So equals the among mean sum of squares divided by the within sum of squares, mean sum of squares. and you should get 403.1. The p-value, which is telling us what is the chance that we observe, what is the probability that we would observe this again if everything were truly random, is equal to f.dist.rt, and then the first argument that you're going to pass to it is the f value. The second argument is the degrees of freedom among, and the third argument is our within degrees of freedom. And that's it. Press enter, and you can see that our p-value is exceedingly small. 1.67549 times 10 to the negative 36. So we can say that there is a definite significant difference between urban and suburban koala mass. Let's practice this together and do the 3-group exercise, which is virtually the same, except we have 3 groups instead of 2 groups. This is still a one-way analysis of variance, just now we have 3 levels of the single factor of area. So now we need to calculate, oh, and I forgot to put in our rural mass here, so we'll add in rural mass right there. I'm going to go ahead and add some borders. Okay, so again, we can use our pivot table for this. I find that that's easiest. Select all of that data. You can see that I've added a rural category here. Insert pivot table. Let's put that into the same worksheet. So put it into the existing worksheet. Let's put it in right here. And we'll put area, just as we did before, koala mass into values, and then change the sum to average. And once again, of course, Excel will never put things in the correct order, so we just have to copy this data, put that into rural, suburban, we're going to put that there, urban, we're going to put that there, and then the grand, we're going to put that there. All right, so we just had to reorder that a little bit. Now, as before, we're going to calculate 3 new columns. So just insert 3 new columns. The first column is the within sum of, or the within square, the first column is our among squared differences, or our among group squared differences. The second column is our within group squared differences. The third column is our total squared differences. And double click on the line between each one of those columns to expand it a little bit so that we can actually see what we're doing. To calculate our among squared differences is very similar to before. We have the group mean for this first data point. The group mean for this first data point is the urban mass mean. All right, let's put that in parentheses. The urban mass mean minus the grand mean, which is right here. And we're going to square that. You should get 108.5. The group mean for this data point is the same as this group mean, and the grand mean is of course the same as this one as well. So we're going to go ahead and lock both of these numbers, and then we can drag that down for all of the urban data points. Now we're going to drag that down for all of the urban data points, and then we're going to drag it down one more to the first suburban data point. The reason being because now we can double click on this, and instead of retyping anything, we can just scroll up here. We're going to change this by clicking and dragging on that blue box to the suburban mass. And you should get 6.1. Once again, because we haven't retyped anything, it's locked that first cell still. So now we're going to just drag that down for all of the suburban data points, and then drag it down one more to the first rural data point. And once again, let's scroll all the way up and change this by dragging this down to the rural mass mean. Press enter and click and drag that down for all of the rural data points. Now we have our among squared differences. We can calculate our sum of all of those squared differences by just typing in sum and then selecting all of those data points. No problem. We should get 14,022.4. Our degrees of freedom for this, there are 3 groups now instead of 2, so it's 3 minus 1, or 2. And our mean sum of squares is equal to the sum of squares divided by those degrees of freedom. Our within sum of squares, we need to calculate that. So the first data point, we're calculating the sum of squares. We're calculating the square differences within the urban group. So our first data point is 34.5, so we subtract the mean from 34.5, or you could subtract 34.5 from the mean if you would like. Either way, because you're going to square it, it doesn't make a difference. So you're going to take that, and then you're going to subtract 33.022, or the urban mass mean, from that, and don't forget to square it. Now you should get 2.2. In order for us to drag this down, as before, we want this to change, but we don't want the urban mass to change. So lock that by pressing F4, and drag this down for all of the urban data points. Now I encourage you to drag it down one more to the suburban data point, and then double click on that, and you can just move the suburban mass down. Or you can move that cell down to the suburban mass rather. Click and drag that all the way down to the first rural data point, and double click on that, and then change that mean from suburban mass to rural mass. Press enter, and then drag that down. And there you have it. So there's our within group square differences. What is the sum of the within group square differences? Well, it's equal to the sum, and then just highlight all those numbers. And you should get 1,176.6. What is the degrees of freedom for that? The degrees of freedom, as before, is equal to the number of groups that we have, which is, in this case, 3, times the number of replicates within each group, which is 50, minus 1. And you should get 147. To calculate the mean sum of squares, once again, you're just going to take the sum of squares and you're going to divide that by the degrees of freedom. Now, we're going to calculate the total square differences, which we don't consider, we're not going to consider the urban, suburban, or rural. We're just going to consider the total, all of the koalas together. So the first data point is 34.5, so we're going to subtract the grand mean from 34.5. And we're going to square that. You should get 141.5. Let's go ahead and lock the grand mean, and then just drag that all the way down, because we're not really worrying about rural or suburban or urban. Let's go ahead and add up all of those values to get our sum of squared total. Voila, there we go. You should get 15,199.1. Our degrees of freedom for that is equal to the number of groups, which is 3, times the number of replicates within a group, which is 50, minus 1. What's the difference between the within and the total? Note that for the within, the first two numbers are within, the first number is outside of the parentheses, and the second two numbers are inside parentheses. With this one, none of the numbers are inside parentheses, or if you would prefer to keep things formal, the first two numbers are in parentheses. So in the first one, it was 3 times 50 minus 1, and in the second one, it was 3 times 50. Oops, 50 minus 1. All right, so you can see how the parentheses shifted, and that changes the degrees of freedom. The mean sum of squares total is just equal to the sum of squares divided by the degrees of freedom. And now we can calculate the F value, which is simply the among mean sum of squares divided by the within mean sum of squares. You should get 875.9. The p-value is equal to f.dist.rt. The first argument is the f value, the second argument is the degrees of freedom among, and the third argument is the degrees of freedom within. And we find out that it is very significant. There's a very significant difference here, and the p-value is 2.1281 times 10 to the negative 82. Very small number. So there is a very good chance that we will not see this pattern again if everything were random. Or another way of saying that is that we have a great confidence that this is a pattern. Okay? there is how you do a basic one-way analysis of variance, guys.